A very good morning to all my dear students. So today I will teach you next another lecture, and our today's topic is chromatography. And as you all know, that chromatography is a laboratory technique which is generally used for the separation of mixture. Okay, so today I'm going to share you the screen so that you can have better understanding on this various type of this chromatographic technique. Okay, so I'm going to enlarge it. Okay, this one. Okay, so now a question you can say that comes in our mind that what is chromatography? So generally, chromatography, it is a Greek word which means color. Graphy means writing, color writing. Okay, so chromatography is generally derived from the Greek word which means color. So it provides a way to identify the unknown compounds. Okay, suppose that I am having some unknown compounds. I don't know that how many components are there in the mixture, and I want to identify the compound. Then it can be used to identify those unknown compounds in a okay. Then principle of separation either is adsorption or partition. So why we use this chromatographic technique? So chromatography is a technique. Generally, it is used for separating mixture into their components, into their various components in order to analyze, in order to identify, in order to, you can say, purify or quantify the mixture or various components. Okay, suppose that this is a mixture of the compound here. This mixture contains the three compounds. One is indicated by yellow color, another one is indicated by this blue color, another one is indicated by this red color. So with the help of this chromatographic technique, we can separate the mixture into its three components. Okay, so these components can be separated, and then we analyze those components, we identify those components, we can purify those components, and then we can find out the how much the given component is present in a given sample, that is quantify the given substances. These are the various things. That's why we are using these chromatographic techniques. What are the various type of this chromatographic techniques? You can say that SPLC, that first is paper chromatography, then the TLC, that is thin layer chromatography, then another one is column chromatography, then gas chromatography, and then HPLC, that is the high performance liquid chromatography. These are the various type of chromatographic technique that nowadays we are using to identify, to separate the mixture of various compounds. What are the various types of this chromatography technique in terms of mobile and stationary phase? So if the mobile phase is liquid and stationary phase is also liquid, then we can call it as liquid-liquid chromatography. We can also call it as partition chromatography. If the mobile phase is liquid and the stationary phase is solid, then we can call it as liquid-solid chromatography. We can also call it as adsorption chromatography. Okay, there's a difference between absorption and adsorption. In the adsorption is a surface phenomena. Okay, the atom, the molecules or the substances, it will get adsorbed onto the surface. While in the case of absorption, it is a uniform distribution of the particles. Okay. Now, liquid chromatography or partition chromatography can further divided into normal phase chromatography as well as the reverse phase chromatography. In the normal phase chromatography, the mobile phase is non-polar and a stationary phase is polar, while in the reverse phase chromatography, the mobile phase is polar, while the stationary phase is non-polar. Non-polar means not soluble in water. Polar means soluble in water. Okay, and in other polar solvents. Okay. Similarly, in the case of adsorption chromatography, it also divided into normal phase, in which the mobile phase is non-polar, stationary phase is polar, and the reverse phase chromatography, in which the mobile phase is polar and the stationary phase is non-polar. So in terms of liquid and liquid and solid chromatography. It can be divided into partition chromatography and adsorption. Partition is liquid, adsorption is solid and liquid chromatography. Solid is the stationary phase, liquid is the mobile phase. So first of all, we will talk about this adsorption chromatography. In the previous lecture, I told you that adsorption is a surface phenomena. Okay, means the substances they get adsorbed onto the surface of the solid. Okay, a solid which is insoluble in the solvent chosen used as a fixed phase. Okay, so in the adsorption chromatography, the stationary phase solute that we are using, it will be insoluble in the given solvent. So the mode of interaction between the component of a mixture and the fixed phase is the adsorption chromatography. For example, TLC. So what will happen in the adsorption chromatography? The component which is having the more affinity toward the stationary phase, it will travel slower, and the component which is having the lesser affinity toward the stationary phase, it will travel faster. Okay, because mobile phase will carry that particular solute with with itself. Okay, so we can say that the mode of interaction between the components of the mixture and the fixed phase is adsorption. Okay, hence the method is known as this adsorption chromatography. And the examples of adsorption chromatography is column chromatography. Here what will happen, as you see in the diagram, the solid particle they will adsorb onto the surface. If they will absorb, if they will distributed here also, then we can call it as the absorption. There's a uniform distribution of the particle. Well, if there is a distribution of particle onto the surface, we can call it as adsorption chromatography. So column chromatography and TLC is an example of adsorption chromatography. The another one is partition chromatography. So what will happen in the case of the partition chromatography? It depends on the difference in solubility of the different solute in the stationary liquid phase. So in this partition chromatography, both the stationary phase as well as the mobile phase, both are liquid. I hope you got my point. Both the stationary phase as well as the mobile phase, as we are seeing in the case of the partition coefficient. In the part with the partition coefficient, there is a distribution of the solute between the two immiscible liquids. Okay, so the rate here, the partition chromatography, the mobile phase as well as the stationary phase is liquid. Okay, so the rate of the separation, it will depends on distribution of the solute between the mobile phase and the stationary phase. Whether you are using the reverse phase chromatography or you are using the normal phase chromatography. I told you in the previous this one also, because if you are using the this normal phase chromatography, then mobile phase will be non-polar and stationary phase will be polar, and which is just opposite. The reverse phase is opposite to that of the normal phase chromatography. So partition chromatography, it is a chromatographic technique in which the solute is separated on the basis of the partition coefficient between the two, you can say liquid. Okay, between the liquid mobile phase and the liquid stationary phase coated with the solid support. Okay, so the supported material used in the partition chromatography is usually silica. Now comes to the very important point here, that is thin layer chromatography. Here, as you all know about the thin layer chromatography, that in the thin layer chromatography, the mobile phase is a liquid. So it's a type of the adsorption chromatography. Okay. Then what will happen? You have to put a solid support on the glass plate, and then the substances which are less attracted to the solid, okay, and more soluble to the liquid, or the substances or the solute which are having the more affinity toward the liquid, it will move faster as compared to the substances which are having more attraction toward the solid. It will move in a less faster rate, or you can say it will move slowly. So the stationary phase here is the glass, which is the glass or the plastic, but nowadays we are using the glass, okay, and which is coated with thin layer of adsorbent. And which type of adsorbent we are using? We are using the silica gel G, we are using the alumina, we are using the cellulose, we can also use the diethyl aminoethyl cellulose, and we can also use the Cefadex. Okay. This is not mentioned here, but I'm telling you the three are mentioned here: silica gel G, alumina, and cellulose, because they are widely used. And the mobile phase generally that we will use a mixture, means solvent to the mixture of the solvents. We can use that ethanol, we can use the water, we can use the acetone, we can use the petroleum ether, we can use the Teflon, we can use the formic acid, etc., etc., and number of solvent we can use in the thin layer chromatography, and number of solvents we can use. Okay. Now, what are the methods of the thin layer chromatography? How will you prepare that plate? Okay. So first of all, we have to select the plate. Okay, whether we have to use a larger plate, a smaller plate, and that depends on the which type of resolution you want. If you want the more resolution, you have to use the larger plates, big plates. If you're using the if you want the less resolution, then you have to use the small plates. Okay, so selection of plates. Then you have to use adsorbent. Which type of adsorbent generally we will use? Whether we want to use a silica gel G, whether we want to use the cellulose, whether we want to use the this Cefadex, whether you want to use the another other you can say that that adsorbent. Okay. So then you have to activate that plate. Then you have to prepare the sample. Okay, in a proper solvent. You have to use a solvent. Of which type of solvent you have to use in order to prepare that you can say sample. Then selection of the solvent, then development of the chamber, then development techniques, then detecting reagents, and then evaluation of the chromatograph. So these are the various methods that we have to use in the thin layer chromatography. So what will happen in the thin layer chromatography? A thin layer of adsorbent, generally we will, in most of the cases, I told you that either we can use the silica gel G or alumina we can use, okay, is spread over a glass plate of a suitable size. And this plate is known as a thin layer chromatographic plate. So the plate will be like this only, just like the mobile phone. And you have to spread. Okay, there are various processes are there. One is pouring, one is spreading, one is dipping, one is spraying. Various processes are there by virtue of which we can say you can prepare that TLC plate. And then first of all, you have to dry that particular plate at the room temperature. Okay, that first of all, do not put directly into the oven. And then it has to be activated at 110 degrees centigrade for 30 minutes. Okay. And then what will happen? Then you can say that after completely drying or after activation of that particular plate, then you have to put the you can say a small spot over this, the sample which is to be separated, the solution of the mixture that has to be separated is applied at a small spot, and it has to be applied at 2 centimeter above one end of the TLC plate. It has to be applied above this 2 centimeter here. Okay, it should be above. You have to measure from the scale the 2 centimeter, and then you have to put that above the 2 centimeter this at one end the TLC plate. And then this glass is to be put into the closed jar which containing that particular solvent that is below 2 centimeter height. And as the solvent will move up, as the solvent will move up in the jar, the component of the mixture will also move up to the different distances, which depend on the degree of the absorption. Whether it has higher affinity for the stationary phase. If it is having the higher stationary for affinity for the stationary phase, then what will happen? It will travel the less distance. And if it is having higher affinity for the mobile phase, then it will cover the more distance. Okay. So degree of adsorptions due to which you can say the separation will took place. Okay, so this is how, and then we have to evaluate the chromatogram. So this is how the different plate methods of preparing the plates here. So what are the various method of you can say preparing the plate? So we can make it by pouring, then dipping, then spraying, then spreading. Pouring, as you all know, you have already done this pouring method of okay. So we have to put this you have to prepare the you can say that suspension of this silica gel G, and then you have to pour it, and then you have to uniformly, okay, like this you have to, then you have to move the plate like this, and then you have to uniformly distribute this in that particular manner. Okay. Okay, so this is the first method of preparing this TLC plate. The second method is dipping. Okay, so what we have to do in order to dip the sample, then since I don't have the TLC plate with me, so these are the two TLC plates. Okay, you have to put this is a front face of this TLC plate. So you have to make like this. Okay, you have to put like this here in this manner, and then you have to dip it into the uh, suspension. So what will happen? It will cover only one part, the front facing part. It will there will be the what we can, there will be a coating of the silica gel G. Okay, there will be a coating of the silica gel G over that. You can say that a plate that will call it as the, this is dipping. Okay, so I told you that dipping the two plates at the time back to back in the slurry of the adsorbent. Okay, then other one is a spraying. You just have to spray the suspension or slurry of the adsorbent. You can say that is sprayed or by using the sprayer. And you can say, but sometimes it will happen if you will use the spraying, but it has to be uniformly distributed. Otherwise, what will happen in some part of the TLC plate, if you spray more, then more thick layer will be formed. And other part, what will happen? Thin layer will be formed. Okay, and another one is the spreading. Okay, so what we have, with the help of the spreader, you can say that you can uniformly spread that, you can say, the silica gel G over this TLC plate. So these are the four methods generally we are adopting in order to, you can say that, in order to prepare the TLC plate, and then you have to activate it. Okay, activation is 110 degrees centigrade for 30 minutes in an oven. So this is how you can say that thin layer chromatography and this can say that RF value. Okay, that here you are seeing here that how to determine this RF value. So first of all, you have to put the spot here, and the spot has to be put 2 centimeter below this particular line. This is a line. Okay, and the solvent, it should not be go above this. In any cases, it should remain below this particular line in which you are dipping that TLC plate. Okay, so after dipping, what will happen? Then the solvent will move, and with the solvent, the mixture of the solutes, it will also move. And then what will happen? It will move in the TLC plate, and due to the different affinity toward this stationary phase and the mobile phase, these two solutes, it will get separated at different points in the TLC plate. Okay, so this is the first you can say that solute. This is the second solute. Okay, so how can you determine? Then you have to determine the RF. RF is the retention factor of the given compound. So how can you determine the retention factor? That the distance traveled by the solute. So this is the distance traveled by the first solute. Okay, this is the distance. Suppose this is it travel the distance of 1 centimeter, and then divided by the distance traveled by the solvent. So this is the second solvent. Okay, then what is the distance traveled by the solvent? Distance traveled by the solute divided by the distance traveled by the solvent. In this way, you can determining the retention factor or RF value of the given compound. Similar cases, this is the case of this component B. Okay, so this is the distance, this is the component B. It also move from here to at this particular distance. Okay, so for the component B also, dB, the distance traveled by from this point to this point, divided by the distance traveled by the solvent front, this one. Okay, so in this way, okay, and it is a decimal fraction, and generally only we have to report it up to 2 decimal places, 0.23 only, 0.12 only. Okay, and in any case, it should not be more than 1. Okay, so RF value, you can say that we also call it a retention factor or a RF value, that it is used for the identification of the various components. And how can it define this retention factor? It is defined as distance traveled by the compound, which is divided by the distance traveled by the solvent. we'll call it as the RF value. Okay, so distance traveled by the solute or distance traveled by the compound divided by the distance traveled by the solvent. So for example, one example I am giving to you, that if a compound travel 2.1 centimeter and the solvent front travel 2.8 centimeter, then the RF value is 2.1 divided by 2.8 and it comes out to be 0.75. So in any case, the RF value should not be more than 1. Because why? Because in any case, this point will neither go beyond this particular point. So in any case, the RF value can't be, you can say that, more than 1. Okay. So these are the applications of this chromatography. You can use the chromatography techniques in the medicine. We can use the chromatography technique in the forensic labs. We can use it in the case of the research lab. Okay, we can use it in the case of this 1 minute, phone is coming, research lab. Then we can use this chromatography techniques in the pharmaceutical industry also. Okay, that I am going to discuss it one by one. So these are the various applications of this you can say chromatographic techniques here. The first application is purity of the given sample. Okay, so you can find out the purity, whether the given compound is you can say that pure or not. Okay, so purity is routinely carried out in any for any drug. It is a routine process to carry out this procedure. Okay, and what will happen then? How can you find out the purity? You can find out the purity. For that you have to compare it with the authentic sample. Okay, and then you have to check it. Okay, so you can say suppose that if the authentic sample is giving you only one spot, and what will happen? Our compound, it is showing the 2 spots. It means that the compound is impure in nature. Okay, so purity of the given sample, whether this compound is pure or not. Okay, with the help of the pure compound, with the, if you know the RF value of the pure compound, or if you know the TLC, if you are having the TLC data of the pure compound, then you can compare it with the pure compound and you can easily identify that our compound is pure or not. Second is examination of the reaction. So the reaction mixture is generally it carried out or is examined by the TLC to assess whether the reaction is complete or not. Okay, so for that we can use the TLC method also. Okay, so this method is also used for the checking other separation procedure like distillation, molecular distillation, etc., etc. So okay, so whether our reaction is proceeding or not. Okay, suppose that if you put the salicylic acid and aspirin in salicylic acid and this acetic anhydride in any mixture, and then you have to find out that whether our reaction is proceeding or not. That you can find out with the help of the TLC method. It's very, very easy. Okay, so you have to put the spot of the reactant. You have to put the spot of the you can say that our compound, mixture of the compound, and then you have to analyze it after half an hour, 1 hour, 2 hours, and then you have to see and check whether our reactant spot they are extinguishing and our products spot is coming, should come. Okay, it means when the whole reactant spot will be extinguished and when our product will come, then it means the reaction has been completed. So with the help of this TLC we can find out, because I am having the shortage of time also, due to which I have to complete it within a given time frame. Okay, now another one is identification of the compound. So if you want to identify any compound, that it is generally employed in the isolation, then purification, then identification of the various type of, you can say, organic compounds. And in the photochemistry, it is generally used for the identification of the natural products also, like volatile oil, like fixed oil, the waxes, terpenes, alkaloid, etc., etc. So you have to identify the given compounds. But nowadays, for the identification of the given compound, rather than TLC, what we are using the HPLC. That is much faster method, and it is having the good result as compared to the TLC. Then the biochemical analysis is generally useful in the separation of the various type of biochemical metabolites or constituents from the body fluids, like you can say that blood plasma, serum, urine. What are the various constituent present in the urine? What are the various constituent present in the blood plasma? So that or everything we can determine with the help of the this TLC. It also used in the pharmaceutical industry also, that for the detection of the impurities, various drugs like you can say that hypnotic, sedative, anticonvulsant, tranquilizers, etc., etc. All these drugs are they are being tested qualitatively by the TLC technique. But again, I'm telling you, nowadays this technique is only primarily used for the identification of the given compounds. SPTLC is much better method as compared to the TLC. Then separation of the multi-component pharmaceutical formulation. If you are having the certain formulation and if you want to separate all those pharmaceutical formulation, then we can say we can use this thin layer chromatography. And in food and cosmetic industry also, that as I told you that in the food and cosmetic industry, it is used for the separation and identification of various colors and preservatives and sweetening agents, etc., etc. Okay, and various type of other cosmetic product it can be used. So widely they are also used in the food and cosmetic industries also. Okay, so these are the some applications of this TLC. Okay, and I hope that you like this chapter. And in the next lecture, I am going to teach you about the copper chromatography. Until that time, be safe, stay safe, take care of yourself and your family. Okay, because it's a boon to you that God give you birth. Okay, in this because of world as a pharmacist. So proud to be a pharmacist. Thank you very much. And then in the next lecture, uh, I'm going to start other lecture, that is paper chromatography. Till then, goodbye and